Hey, how you doing? Welcome to class. We're discussing OBD2, onboard diagnostics generation 2. They say all cars built since 1996 have this system on them if they're sold here in the United States. And that's not exactly true. There are plenty of cars that did not meet the full requirements all the way up until about the year 2000. Some Chrysler products didn't completely comply with OBD2 regulations all the way up until then. And then there are other cars that are sold here in the United States that don't comply at all. I mean, there's no law that says that any car has to be in compliance. It just says that if it's not in compliance, it's a fine, $10,000 per unit sold fine on the manufacturer. And there's quite a few cars that they just pay the fine. Anyways, onboard diagnostics generation 2 started in California in 1980. This was the precursor to it. California had some emissions problems that they were dealing with. You know, the air quality was terribly bad, and they decided to take the lead on this. So they mandated their own more stringent regulations that the rest of the country didn't. Now, this did lead to a problem. Well, to a problem that there were California emissions cars that were being sold in California, and then the rest of the country didn't have them. And you know, they also dictated that, you know, the self-diagnosis needed to be done on the vehicles. And that was fine, except every manufacturer did it their own way. I mean, you know, some cars blinked a light on the dashboard. Some cars you had to go in and, you know, jump a couple of pins on the older Fords. Some cars, I'll pick on some of the Euros, that literally you'd have to pull the PCM out, and there was a screwdriver you stuck in the screw, and you know, basically it was a switch. You turned it on, and there were two lights that would blink through this little window, so it would blink the codes at you. Common. Now, they wanted it to be easier to repair, so, you know, all these different manufacturers doing it any way they wanted, and then, you know, the computer interfaces were any way they wanted, any protocols, any, you know, proprietary stuff that you would need to spend $5,000, you know, back then in the 1980s, which was a considerable sum of money, to purchase the standalone code reader that only read Mitsubishi or only read GM, and then they could change it anytime they wanted. So every year they could come out with another one or change the protocols, and then that tool became a boat anchor. It only worked on a certain... Anyways, it was a problem. So they dictated this new OBD2 regulations, which does bring up some interesting stuff, which we will discuss in person in class. I'll tell you where OBD2 came from. It's kind of interesting. But this led to become, you know, more global sharing of this stuff. So, you know, the scan tool, the generic scan tool, the global scan tool that I could plug into an Asian car, a Honda, Mitsubishi, a Subaru, would also work in a BMW or a GM or whatever. Supposedly this makes it easier to repair, and the protocols were all the same. Now, a couple of key terms we need to cover. IM programs, this stands for inspection and maintenance. FTP, which is Federal Test Procedure. This is the federal test that's run on the emissions of the vehicle. Now, remember, we're talking emissions. We're not talking gas mileage. That's CAFE, Corporate Average Fuel Economy. That's something different. Okay, and then we got the MIL, which is a malfunction indicator light. That's the check engine light on the dash. The technical term for it is MIL. DLC, Diagnostic Link Connector, that's the plug underneath the dash. That's all specific as well. So, every car is the same. And then DTC, diagnostic trouble code. This is where the computer has detected a fault in one of the subsystems and it illuminates the mill. And we have to talk more specifically about exactly how that gets taken care of. Okay, so the standards are, it standardizes the communications protocol. It's like Mac or Windows or Linux. As a matter of fact, most cars nowadays are running Linux as an operating system in their PCMs because it's cheaper, free. And so this communications protocol is all standardized. The other thing standardized is the monitors. And think of those as like groups, subgroups of different tests, okay? And then we have the self-diagnosis. This is where the computer actually runs tests in the background to diagnose whether or not there's problems with the emissions part. And a lot of these tests are standardized, like the DTCs, the diagnostic trouble codes, they're standardized across manufacturers. So a P303 code on a Ford is the same P03 code as a Chrysler or a Honda or whatever. Okay, and then the DLC is also standardized. Now, some of this communication stuff. Standardized communication protocol, serial data is 1 bit at a time. This is referred to as a class 2 on GMs and some other manufacturers. This is actually fairly slow. Okay, monitors. These monitors, these are groups of tests. We've got, catalyst monitors, we've got EVAP, H2O. These guys, think of it as a class you're taking at school, and then inside that class, that catalyst class, there's a whole bunch of tests that are done in the background. Some not so much in the background. Now, some of these tests have specific criteria in order for them to run, and they're also interrelated on top of each other. Okay, we'll take a look at that in a second. Now, some of these tests may not run for a long time. I mean, we look at a lot of EVAP tests. This tests leakage from the gas tank, okay, and any hydrocarbons that escape from a leak in the gas tank. And it's a pretty fine test. Temperature plays a big key. I mean, generally a lot of these EVAP tests won't run when it gets colder out. Okay, so and then there's like a temperature swing that needs to be in. Some of them are plus or minus 15-degree temperature swing over a 6 hour period. Well, you think about it. When does that happen? Or the baseline starting temperature for the test needs to be above 35 degrees. So is this test going to run in January? No, probably not. Is it going to run in February? Good chance no. Get it? So, some of these tests may not run for a very, very long time. More on this later. Now, the self-diagnosis. We run these standardized tests, but there's also room for the manufacturers to run their tests. These standardized DTCs, these standardized tests that get run, because that's really what a DTC is. A DTC, a diagnostic trouble code, is a failed test. Get it? So these tests, that the computer runs in the background are, we have these standardized ones, but then there is room for manufacturers to have their own. But let's stay on the global side, on the generic side, for now. The tests that get run on that side are rather specific. The description of the test is specific, has to be called this. The test that runs in the background can be pretty specific. That doesn't mean that there can't be tests on the manufacturer side that are more specific to that manufacturer. You get it? But the only test, DTC, that's allowed to turn on the check engine light, the light on the dashboard, is on the global side. The manufacturer side is not in charge of the light. Get it? So this also must test for degradation in operation and performance, and it also must be able to compensate for some wear. I mean, anyways. All right, so here's the DLC. Now, a long time ago, back when GM first built the diagnostic plug, they called it an ALDL. This was Assembly Line Diagnostic Link, way back. And the reason why it was there is because, you know, the cars were getting more and more complex, so GM wanted a plug that they could plug in on the assembly line to test all the electronics, and if something was found to be amiss or not working, they could pull that car off of the assembly line to fix it, to put it back on. Some enterprising technicians realized that we could use that to fix cars. Get it? Okay. So the diagnostic link, the DLC that we have now, is standardized across all brands and all platforms. And some of the pins that are in there, some of the wires that are connected to it, are standardized and they need to be in that spot. Some are blank, and that's the room for the manufacturers to put in what they want. They can put in their own communication. They can put in their own systems on that DLC to be read by their specific software. This is where enhanced, you know, scan tools come into play. Get it? All right, inspection and maintenance, the IM stuff. The check engine light has to come on when the emissions reach 1.5 times its FTP. FTP is the federal test procedure. That comes from the manufacturer testing their vehicle, saying this is what as new should look like. We okay? Not the government telling them what it should look like. It's the manufacturer saying this is what our car does. This is the emissions that it puts out. It is in compliance with the EPA. We okay? They can be cleaner than that, but it can't be dirtier than that unless they pay a big fine. But realize it's 1.5 times its FTP. So there is a little wiggle room in there for when that check engine light comes on. Okay. The mill needs to operate like when when you're going for an OBD2 test in the test lanes, like we have here in Illinois and some places in Illinois. They plug in and they go and look and make sure there are no DTCs. The other thing they look at is if all the monitors are completed. Remember, the monitors are groups of tests. So it looks at, are the monitors complete? Have they all run all of the tests underneath them? We okay? And then it looks at, are there any DTCs? No DTCs. All the monitors are complete. That means there's no trouble there's no issues with the car. Now, if the monitor isn't complete, it hasn't run all the tests under that monitor. Get it? So it's just like not completing the class yet. Have you failed? Well, the class isn't done. Get it? So until you complete the monitor and no DTCs have been found, no failed tests, we don't know if the car is okay. Get it? All right. So if there's no DTCs, but the monitors aren't complete, the car will be rejected out of the lane. Does that make sense? So you go to the test lane. If you've cleared the codes, it resets all the monitors. Get it? All right. In which case it'll be rejected. It's not technically considered a fail. Okay? And it'll also be rejected if the DLC is not located, isn't accessible,
You got stuff in the way, you got something plugged into it, whatever.